Okay, question number 6. So simultaneous equations, it's got x's and y's. So I need to label up the two equations. This one is number 1, that one is number 2. As you can see, the numbers in front of the x's are 4 and 2, and the numbers in front of the y's are 5 and 1. Now I must make them the same either for the x's or for the y's. So in this case I'm going to make them the same for the x's. Okay, so I'm going to turn this 2x in here into 4x by doubling it. But I don't just do it to this little bit here, I have to do it to the whole equation here. So this whole equation, number 2, needs multiplying by 2 so that I get the 4x at the beginning. But I need to also multiply by 2 the minus y, so it becomes minus 2y and equals 18 now as well. Okay, so we can ignore this one now, and the reason I've doubled it up is that I now have a 4 in front of the x in number 1, and we'll call this one here equation number 3. Okay, so I'm going to take away equation number 1 and equation number 3 from each other, and I'm going to do number 1 minus number 3. Okay, so this 4x, take away this 4x is no x. 5y, take away minus 2y is 7y. Minus a minus is like adding it on. And then 4 minus 18 is minus 14. So now I've got an equation only with y in it. I can divide it by 7 on the left and on the right. Equals, that gets rid of the times in 7, so you're left y equals, and divide a minus by a plus. 14 divided by 7 gives minus 2 for y. Okay, so minus 2 for y. That needs to go back into one of the original equations, either number 1 or number 2. Let's help that out, make them a bit clearer. Okay, number 2 actually looks like the nicest equation there, or the simplest equation, so I'm going to sub in equation number 2, so that 2x minus the minus 2 we've just found equals 9. Take minus minus 2 is plus 2, so if I take away that plus 2 by doing minus 2 on both sides, you'll end up with 2x being equal to 7. Divide it by 2, and you'll end up with x being equal to 3.5. There we go, final answer.